In this video, I'm going to talk about how SLIKWORKS can be used to perform an FMEA. As I've talked about SLIKWORKS before, it's a tool that is used to perform different types of safety analysis. In this particular video, I'm going to focus on the FMEA part of it. So when you open SLIKWORKS, which is a web-based app, uh, it opens up this dashboard wherein you can see all the projects that are available. You can add a new project, and let's say we're creating a project called Park Assist System. And let's say this description is, let's say we're using it in an automotive context. So we create a project, and then we can select a project. So once we select a project, we go into the project dashboard. And inside each project, you can see the different types of safety analysis that one can perform. FMEA, FMEDA, HARA, SOTIF, TARA, FTA, etc. For now, we'll focus on the FMEA. So if the user wants to create an FMEA, they would select the FMEA, and the first thing it's going to ask for is what template. There is a default template that we have, which is based on the AIAG VDA template. Now, the user is also free to select their own template. They can create their own templates, and we'll get to more this in another video. Once the user selects a template, the next thing the user needs to decide is what is the architecture for which they're going to perform the FMEA. The architecture is then going to decide what are the components for which we need to identify failure modes. What we have enabled in SLIKWORKS is the ability to upload any image file. So no matter what architecture tool one is using, as long as you're able to convert it into an image file, we're able to upload this architecture. Uh, as an example, uh, in this, we talk about a Parker's system, and then this is what the architecture looks like. Three sensors, one control unit, and then one display, and a bunch of other things within the control unit. It's a voltage regulator and a flash memory. Now, once we upload this architecture diagram, we have an image recognition algorithm, which is using state-of-the-art AI image recognition algorithms, and it is used can extract all the components, the signals, and the types of components. Alternatively, one can also add each component manually, which is possible, but it's easier to add components through this AI feature. So it recognized seven components, and for each of them, it identified what the inputs, the outputs, and you have the ability to modify, delete it, etc. So if you take one component, let's say the ultrasound sensor, and if you look at it, it has these inputs. It has an RC sensor trigger as the input, and RC sensor echo feedback as the output. And if you go to this architecture diagram, this is the input and this is the output. So it's able to recognize all of this automatically through its image recognition algorithm. The other thing that it's able to do is also recognize the sensor type. And there are several inbuilt sensor types that we've done. And the reason this is important is using these sensor types, it is able to predict some failure modes when we go into uh, the FMEA form sheet. So now that we have this, we can then go into the next, which is the effects. Again, with the effects, we have the ability to manually add effects if it's already known, or we have the ability to upload images, uh, which is probably coming from a requirements management database. For this example, I'm going to add them through an image file. And then similarly with safety measures, we're again able to import image files. And as you can see over here, it uploaded the hazards that is there in the image file and its description. Similarly, if there's already a list of safety mechanisms available from a requirements management tool, it's able to import that. In this case, it's a two-step import process, converting the requirements management tool into the information in the requirements management tool into um, an image, and then importing that image. And safety mechanisms, once I import it, this is what it's going to look like. Takes a couple of seconds to for the image recognition algorithm to see what is there, scan what is in there, and then print it out over here. And this is a list of all the inbuilt safety mechanisms that we have.